My name is Ian Martin, and I'm the CCUS theme lead here at the NZTC, and I will be your host for today. So why do we call them Tech20? So it's an hour long, broken down into 3 blocks of 20. We've had our 20-minute networking session, which I hope you've all enjoyed, with a little spot of breakfast. We'll then have 20 minutes presentation, and then we have 20 minutes Q&A. But before we start, gosh, got to multitask, excuse me. A few housekeeping rules. We don't have any fire alarms planned today. So if you do hear the fire alarm, please head to your nearest exit. There's one at the back of the room here, or otherwise it's back up the stairs and through reception from where you just came from. The session today is being recorded, so could I please ask you to switch off your phones, and please, there's no need to take snapshots, etc. during the presentation, because it's being recorded and will be available online afterwards. When we hit the Q&A, please could I ask you to raise your hand, and someone will come to you with a microphone to ask your question. So those watching online will be able to, or when it comes online, will be able to hear. And if you do want to post this on social media during the event, please can you use the following hashtags: hashtag Tech20 and hashtag time to Tech20. Right, so what's the next slide? Oh yeah, house rules, just been through that, make sure I've got all that. Yep. Oh, so I would now like to introduce our guest speaker for today, Beena Sharma, who is CEO and co-founder of CCU International. Beena, would you just like to give a small insight without giving too much away of what you're going to talk about today?
Yeah. Today I'm going to be talking about carbon dioxide and how we view carbon dioxide and what we're looking at doing with carbon dioxide in our atmosphere, why it's a problem, and the solutions that are out there in order to get us to net zero. Like you to go?
Okay, well, yes. If you're ready, you have the 20 minutes start now. Thank you.
Brilliant. Thank you. So I'm Beena Sharma. I'm the CEO and co-founder of CCU International. CCU International are a startup. We've been around for about 6 months, but we do have a good 10 years of R&D behind us, specifically technology focused. So we capture and we utilize the CO2 that we capture from industry. We do that via direct flue industry, chimney and flue emissions. Today I'm going to be talking about carbon dioxide specifically, and we talk a lot around sort of net zero and what we mean by, we talk a lot around emissions in the atmosphere, but really there's not that many people that really fully understand what that means to us as individuals and what that means with regards to our goals to get to net zero. Why is it a problem and what can we do about it? So I'll look at a couple of options. The first thing that we need to think about is what we need CO2 for. So there is a misunderstanding around what we need CO2 for. It's quite often seen as the enemy. And some of the reasons, there are lots of reasons for that. But really CO2 is very valuable to us because we need it for our own internal respiration. We need it. It's part of the circle of life, photosynthesis. And really it's all to do with both the human and animal food chain. So we're heavily reliant on CO2 being in our atmosphere because that's what these plants need to survive. And we need those plants to feed off. That's kind of the natural part of CO2. But with regards to the other side of CO2, we use it in a lot of products that you use on a day-to-day basis. So we've got CO2, as you know, fire extinguishers to extinguish fires. And also we use it for animal slaughtering, but also the carbonated and drinks industry and the beer industry. So a couple of years ago, you may have remembered, not last year, but the year before, we had a beer shortage. And that beer shortage was down to shortages in CO2. So you might start to think, okay, well, if we need CO2 and we use CO2 on a daily basis, then why are we storing it underground? And I'll come on to that in a little while. But the other thing that we use CO2 for, and quite interestingly, I've run a few sessions like this, and I quite often ask people, what do you think we need CO2 for? And one of the other things is, for example, to keep our foods fresh. It's one of the reasons why we're able to do our weekly supermarket shop and still have some of those fresh salads in the fridge some days later. It's CO2 that keeps it fresh. The other thing that also, which most people are not aware of, is we use CO2 for dry ice. Dry ice is predominantly what the healthcare industry use to keep things like our COVID jabs at the right temperature. So lots and lots of applications, particularly medical healthcare is quite a big application. It's a small application, but it's very specialized. So why then do we see CO2 as the enemy? Well, if we take a quick look at this graph, we'll see that I'm not going to go into what greenhouse gases are. I think most of us kind of understand that greenhouse gases have been detrimental to our environment for some time. But CO2 is the most significant one of the greenhouse gases. And what we've seen is since the Industrial Revolution, you can see here, we've had an increase of 50% of our CO2. And that's all down to burning of fossil fuels. So when we have a look at that, we see we're pretty stable. Bang, Industrial Revolution, and our emissions have gone up. The CO2 in our atmosphere has gone up. The other thing that's contributed to that is deforestation. Of course, plants rely on CO2. They sequester the CO2 out of our atmosphere. So the more we cut down these trees, the less of that there is to help us remove some of those CO2 concentrations from the atmosphere. That basically means that there's not enough to absorb it and the balance is completely out. And I know we've recently seen some reports about us not quite we may not even be lucky if it's 2.5% as opposed to 1.5% temperature increase. So those increased CO2 concentrations can cause climate change issues. And that's where the real issue is. That's where all the policies are focused on. So what do we need to do to bring back the balance? And there's a couple of things we can do. One of those things is carbon capture, utilization, and storage. And really what we need is a key technology. We need technologies. And the UN have stated very publicly that carbon capture will be a key technology in getting us to net zero. Fact. We don't have other solutions out there that can get us to. There are multiple things that we're doing, but ultimately it will come down to taking large quantities of CO2 out of the atmosphere, whether for use or whether for storage. So we do two things by capturing. There's two ways in which we capture CO2. The first way in which we do it is by tapping into direct flue emissions. So we capture those emissions before they enter the atmosphere. And then the other way we do that is we capture them once they're in the atmosphere. And you may have heard, quite often talk about historic CO2 in the atmosphere. What do we do about the billions of tons of CO2 that's historically been in our atmosphere and isn't able to escape due to this greenhouse effect? Well, then we would look at something called direct air capture. And that's it's the same technology, it's just a different method. But the use of technology is constantly advancing. And I'll give you a little bit of history on where we are with technology. So traditionally, what we've been using for carbon capture is we've been using a chemical substance called amines or amines. And that is a hazardous substance. It's hazardous to the environment, it's hazardous to people, it's a carcinogenic substance if it's released in the wrong way. And what we're doing right now is we've been using amines for about 70 years. We've been using advanced amines for about 25 years. And we use that chemical substance to capture the CO2. It quite effectively does manage to capture the CO2. But what happens is we need to constantly replenish those amines, and we are still putting them back into the atmosphere and back into our water streams. So carbon capture hasn't really been that effective, or certainly not as effective as it can be. And we're doing that predominantly to store the CO2. And most of you will know, we talk a lot, particularly in this region, we talk a lot about storage. And the fact of the matter is that, we need to remove 400 billion tons of CO2 from our atmosphere, 400 million tons of CO2 from our atmosphere in the UK alone. We're not achieving that. And that storage is definitely not achieving that. So we need to start thinking about other solutions until we get to a point where we can store safely, securely, and in vast quantities. So let's take a quick look at the CCUS value chain, because this is really important. So we capture from our sources. Once we've captured that, we compress or we liquefy the CO2, and then we transport it to wherever it needs to go to. And then you've obviously got storage sites, and then you've got the utilization. I'll come on to the utilization a little bit later. But if you think about that value chain, you're probably thinking to yourself, where is the value there? Because we're capturing at cost, we're compressing and liquefying at cost, we're transporting at cost, and then we're storing at cost. Forget the utilization piece for now, but we're storing at cost. So you might be thinking to yourself, where's the value there? Who pays for this? And this is one of the things that we are constantly pushing government. Well, can you fund us for this? Because it's a cost exercise, and the technology that we're using is dated. It's hazardous to the environment. We don't fully understand what the carbon efficiencies of these technologies are. So we need to start asking questions. We haven't done that yet. We haven't done the storage part in the way that we said we would. So what do we need to do? And this is where the utilization comes in and where we specialize. So this is a completely different way of looking at carbon capture. So if you can see what we do when we talk about, when you think about, just the recycling of plastics and things, that we talk about a circular carbon economy. And what we talk about here is something called custodians of carbon. And what that basically means is each and every one of us, from a behavioral perspective, we take responsibility for our own CO2 that we emit. And then we run that through the cycle, we redesign, we reuse, and then we recycle that CO2. Now, until we get to a stage where we can comfortably store, where we say CCS, we should be continuing that cycle. That cycle should be going round and round and round. What does that do? What difference does that make for us? It's not just a case of us putting it into aviation fuel and then burning it again, capturing it, that's not how it works. Molecules work slightly differently. Every time you clean up that process, what you emit or what you burn is cleaner. Particularly when we're talking about sustainable aviation fuels, because we do have to reburn them, but they certainly don't let out the same emissions that virgin fossil fuel does. So we're talking about the utilization here and taking ownership of CO2. And I'm going to move on to this slide because this is a project that we are working on at the moment. And this is a groundbreaking project in the utilization space. What we are doing is we are taking emissions from the steel and paper mills, which are some of the dirtiest industry emissions that you can find. We're taking those emissions and then we are capturing them and we are creating something called surfactants. And that's in partnership with BASF chemical manufacturers, for example, and you can see all the partners here. This particular project has the potential to remove 15 to 20 million tons of CO2 a year. So you might ask me how. Surfactants go into virtually every single soap product that we use. I'm talking cleaning materials, I'm talking your hand wash, your shower gels, your fairy washing up liquid, Lenore, the lot. Now, if you think about it, almost everything we touch and feel, including plastics, manufacturing, including your carbonated drinks, has some element of CO2 in it. So you might ask yourself, well, in that case, why are we talking, if we need it so badly, why are we talking about storing it in the ground? And the reason for that is because the technology we're using is dated, doesn't have the ability to effectively reuse the CO2 that we're capturing. Now, if we think about the carbonated drinks industry, how many people in here would be happy to drink a can of Coke that has been captured using an amine plant? See the moral dilemma here. So this is the reason why when people say to me, why are we not reusing the CO2? It's because the technology that we're using is dated and it is hazardous. There's nothing that says that we can do it. There's nothing that says we can't do it. But I can imagine that Coca-Cola won't be wanting to use CO2 captured from an amine plant. I mean, if the public found out, there'd be uproar. So this particular project has masses of potential to show the UK what we can do. And when I talk about the surfactants, what we're doing currently, those surfactants come from virgin fossil fuel. So we're not talking about decarbonization here. What we're talking about is defossilization. That defossilization process that takes place means that we remove reliance off virgin fossil fuel. Now, we're talking about still emitting over the next 20 years, 30 years, 40 years. We're still going to be reliant on fossil fuels. So why are we not talking about capturing that and utilizing that in that circular economy, in that circular carbon economy? And there are projects like this that are happening. This is probably one of the very first in the UK. But you can see the number of companies that are committed to this. These are all blue chip companies, and we're providing the technology for this. So if you think about the likes of Unilever, they're putting it into all their projects, all their products. What that does currently, what they're doing is their chemical feedstock comes from all over the world. So not only does that remove virgin fossil fuel, the reliance on virgin fossil fuel, but it removes all the emissions that are involved in getting those chemicals into those products. So it's absolutely huge for them. The problem is when they go public with this and say, guess what, we've just produced, hopefully by the end of the year, our first ferry liquid with captured CO2, the world will go, there's CO2 in all these products. And that's what you're flushing down the drain when you wash with it. But that's something they have to deal with regards to their PR team, not our problem, I'm afraid. So carbon capture utilization, what's happened in the market right now? If you go online right now, you will see that 1 ton of CO2 for food grade, you can buy off BOC, Linde, Air Liquide for around £1,200 a ton. Just have a think about that. Cost of capture is typically around, can be anything around, well, depending on who you speak to, but around £60 to hundreds of pounds a ton. So cost of capture, that's you're including everything that you need, CapEx, OpEx, and any energy requirement as well. So you think, well, there's a market for this. Somebody should be tapping into this. But what we need now is our next era of how we recycle CO2. And in order to do that, we need next generational carbon capture. We need to no longer use virgin fossil fuel. We know we need to do that. It's going to contribute massively to removing emissions in our atmosphere. And the other thing to remind you, we are in a transitional period. So we're not saying that the reliance of virgin fossil fuel would disappear right now. We're transitioning through this process. We know that by 2030, there is no way that we're going to be able to remove 400 million tons of CO2 unless we do something drastic now. Storage isn't there. We're some way away from storage. So in the short term, what can we do? Just to give you an idea of some of the products that we can create from CO2, we can take captured CO2 and we can create aggregates, for example, that goes into your construction material. It's actually better construction material than what you get standard. But imagine creating a circular economy where you capture emissions, you create the aggregates, and then that aggregates gets turned into building material, which then goes in to build your roads, your houses, etc. That's a form of storage. So that creates that circular economy. Sustainable aviation fuels and diesel. The target for a lot of aviation companies who have signed up now have said 6% of aviation fuels. They want to be providing 6% of aviation fuels as sustainable fuels. That's a huge target. Our technology isn't there yet. It's being developed, but it's not there yet. And then in the medium term, we've got things like surfactants, obviously diesel, aviation fuel. Long term, nobody actually knows what we might be able to do with captured CO2. And this is why I've got a question mark there. Because right now we know what the potential is. If you look at the CO2 market right now, you're talking 800 billion to 1 trillion by 2030 will be the CO2 market. That's what we need. We are buying CO2, we're buying these chemicals from elsewhere because we don't have enough here. But yet we've got industries across the whole of the UK that are emitting every single day, thousands and thousands of tons of CO2. So the investment needs to go in capturing those. Now, one of the things that we do differently, when I talked about the CCUS value chain and how everything was done at a cost, when you get to the utilization piece, it's no longer a cost there, it becomes a revenue stream. So imagine capturing your CO2 emissions from your steel plant, for example, purifying that to whatever grade you need to purify it to for the food industry, for the drinks, depending on what's happening in the market. You know, SAFs, for example, valuation might go right up. In that case, it's up to you as a business to decide, can I afford to capture? Yes, I can afford to capture, because in 2.5 years' time, I would have got my return on investment, and then I'll be making some on that because I'm selling that CO2 back into the market for utilization. So it gives you something to think about. So what we're doing effectively is taking away we are providing, as opposed to it being a cost, carbon capture being a cost, we are providing potential for multiple revenue streams for businesses. Are we busy? Hell yes, we're busy, because we are able to model those. And it's very easy to see where the benefits are. What this also means, carbon capture plants traditionally are very large and very expensive. We know that. What happens to those industries that are, say, placed on the west coast of England that haven't got access to pipelines, that are not big enough or haven't got enough space for large carbon capture plants, haven't got the money for carbon capture plants? And this is where next generational technology needs to come in. It's the SMEs that we need to support decarbonisation, as well as the large corporates. Imagine we could decarbonize those small industries and say, it's not really going to cost you anything, because within a year, within 2 years, within 3 years, you'll get your return on investment, and it will be generating revenue for you in years to come. It's an easy conversation to have, as opposed to saying, I want you to capture your emissions because it's the right thing to do for the planet. So conventional methods we know are designed for storage, which is why we've not really done so much of the utilization up until now. But the technology is available right now for capture and utilization. Quick intro to us, as it's not a sales pitch. We are next generational technology. We've been around for only 6 months, but we've got 15 to 20 years in the CCUS space. In fact, our team are very much involved in supporting policy. We mediate between governments on this topic, and the focus really for us is the utilization piece, because we know that is the solution we can do right now. I'm not saying that storage isn't a solution or another method. What we're saying is there are multiple solutions that we need to bring to the table to do this. What we do, which is unique to existing technology, is we can capture, but we can also refine depending on which industry it needs to go in. So if you look at the construction industry at the moment, they are buying CO2 in at 99.9% purity, which is expensive. They only need 50%. We can do that. So adds to the economy in that way, but also because we can provide those variable purity levels, it means that we are able to utilize it into the food and drinks industry. One of the reasons why we can utilize in the food and drinks industry is because we don't use any hazardous substances. And that's a key thing. Quite often when you look at carbon capture systems, it is almost a given that amines is the way to go, because that's how it's definitely, you know, we're doing the same thing over and over again and expecting a different result. It's not going to happen. And that's pretty much it. That's me. So any questions? Thank you.
Yeah, thank you very much, Bina, for that very interesting talk. Yeah, question time.
Fraser.
Hi, morning. Thank you for the presentation. I have 3 questions. I understand why I've got all in one. First one, everyone, media, politicians, financing houses, CCS. So how do you get that message out there? That's question 1. Question 2 is, because you're capturing CO2 at industrial level at the source, why not piggyback or set an actual commodity plant at the source and provide local commodities, whatever, for whatever that industrial facility is, whether it be construction or methanol, whatever it's going to be. So that's the second question. And the third question is pricing deck. Short-term, medium-term markets you've said there all have a different pricing deck based on the quality of the CO2. So how does that affect the base cost of capture? So those are the 3 questions.
So what was the first one?
I have no idea. Yeah, the first idea was...
the educational piece. How do I... Yeah, okay. So, yeah. So that's a difficult one. So CCS has obviously been banded around for a long time. And actually, if anyone's interested, if you Google Mission Innovation Houston, you'll see that there was a consortium of people that came together, representatives from governments that came. One of our team actually was in that, came together, and they spoke around where we went with CCS. And that's where the U was put in. That was back in 2018, the U CCUS. And there was discussion around whether we separated out CCU and separated out CCS, because they actually are 2 very different things. The CC stays the same. Carbon capture is carbon capture. It doesn't matter what technology you use, it's carbon capture. But it's what you do with it afterwards that's very unique in comparison to storage and utilization of 2 very different things. The challenge that we have is that there is very little understanding around the utilization piece in general in industry. And quite often when people use CCUS, they think of the utilization as being for enhanced oil recovery. Doesn't quite work in the way, that's not quite utilization because you're just putting it back into to get more fossil fuel out. So the actual utilization piece, and in hindsight, when I spoke to some of those guys that put that document together, they said, actually, in hindsight, if they had known what would happen now, then they would have separated out the U. But there is a huge amount of education going in at the moment. The Carbon Capture Storage Association, I was in London 2 weeks ago, they ran a workshop focused solely on the utilization, and it became very evident that a lot of companies who are, not just those companies that are involved in that, but also others, companies that are looking for these technologies, don't really understand that there is an option to utilize. The other question you said about having localized solutions, 100% bang on. So one of the projects that we're working on is a waste to energy plant, for example. We capture their emissions and then they want to create urea. So we are looking to create urea on site. So that means that we don't need to, we remove all the emissions involved in transporting, bringing it back. If you look at the carbonated drinks industry, for example, we know of one carbonated drinks industry that are emitting, that are producing at production levels of 70%, and they have been for about 18 months, nearly 2 years now. Because not only do they emit CO2 from their process, but they also buy it in its liquefied form at an expense. And then they transport it in, they turn it into its gaseous form, and then they use that. So it's crazy. At one end, they're releasing the CO2, and at the other end, they're having to buy it in. So if you think about it, it's not just about taking the CO2 and utilizing it, it's about removing everything else that goes in that chain. And then the third question was about the money. Right, so there's a couple of things around this. Obviously, for a client, it's important that they understand what the financial incentive is for this. Right now, clients are wanting this. You know, they're dying to get their hands on a solution like this because it means that they can tick all their net zero boxes and make some money at the same time. What affects the biggest effect that has on the cost of that cost of capture per ton is the energy cost. And what we're finding is that there are a lot of technology companies out there who cannot give a cost of capture. If anybody's giving you a cost of capture per ton, I can guarantee you it won't be right because it changes by the day, depending on what the energy cost is. What does affect it is, it does affect depending on what you're doing with the CO2. So if, for example, you've put in a downstream solution into a plant that creates aggregates, aggregates typically don't get as much as obviously your SAFs. But the purpose is because these solutions are modularized, you are able to A, move them around, so you can move them to another site. You are also able to B, those downstream solutions, swap them out for another solution. And that will always affect how much you get for it. But as far as the cost of capture per ton will depend on a number of different things, obviously the OPEX, and that main difference is the energy cost. But generally it stays the same. The only other thing that would affect it, not in our technology, but in conventional technology, is the use of amines. Because what we're hearing now from organizations that use amines, they are struggling like maybe 1.5, 2 years lead times on this particular chemical. But amines need to be replenished over and over. So that will affect your cost of capture per ton. Yep. Yes.
Thank you for your presentation.
Thank you.
I'm Paul. I work with Shell. I've been involved a bit in carbon capture and underground storage, and that's always been presented as long duration, permanent type storage. I'm just wondering how similar boxes with, if you're reutilizing it, say, and it's then going into a carbonated beverage and being released, how do you kind of bridge that gap? I can understand the financial incentives towards doing that, but just trying to understand the net zero picture between utilization.
It's a good question. So we quite often go back to it, when we looked at the carbon cycle. Carbon capture and storage is linear. It's very linear. We look at CO2 as being a waste, and this is the behavioral change that needs to take place. We look at it as being a waste, and effectively what we're doing is we're taking that waste and we're putting it into landfill. That's what we're doing. And if you look at the carbon emissions involved in that, if you do the full life cycle analysis of that, you will see that actually it's not that efficient. With the circularity of CO2, you can also do life cycles, and because you can continuously reuse that CO2, and every single time you reuse it, you clean it up. You can do the comparisons in the life cycle. It's a really interesting question because Shell, in particular, I've just spent 2 days with Shell in London, and Shell are very, very focused on the CCU element. It's a massive team that specializes. It's the most represented growing team in Shell. And I was absolutely blown away by the stuff that they do, but they're looking at sustainable aviation fuels. They're looking at your commodity chemicals, your ethanol, your methanol, etc., as well as doing the storage. So they've understood that there is a market for this. But certainly, if one of the things that we're lacking in the industry, and you're not the only one to ask this question, because one of the things that we're lacking in the industry is those full life cycle analysis. And that's not being done. What I will say from our perspective, we are publicly releasing, we will probably be the only carbon capture company, certainly in the UK, possibly in the world, that are actually going public with our full life cycle and assessment. That will include, it's not something that you have to complete an NDA for, but that will include our full life cycle analysis, our carbon efficiency, and our energy cost as well, which at the moment isn't being disclosed. So what I would say, if anybody in this room is ever looking at, well, how do I qualify a carbon capture technology, there are 2 questions you need to ask. One is, what is the energy consumption? Because that's really important. One particular plant we worked on, they were talking to a capture company for 2 years, looking to put a plant on their site. And eventually they said, well, what's the energy cost? 65% of the energy that plant generated would have gone to powering the carbon capture plant. That's not viable. And that is mainly down to the fact that the technology is dated and old, and they are using amines, which is very energy intensive. So that's the first thing you should ask. The second thing you should ask is, what is the carbon efficiency of this technology? So if you are capturing 10 tons of CO2 a day, but you're using 9 tons to do it, it's not very efficient. And you'll find that actually amines isn't that efficient. So we will be releasing that. Worst case scenario for our technology is 89% efficiency. That's worst case scenario. So that all ties into that full life cycle to show what the carbon savings are, or what how that life carbon efficiency is beneficial in comparison to storage. Yep. Thank you. Go for it.
It's just a curiosity question. So the CO2 industry now for food grade or for surfactants or whatever, is it all coming from amine capture based technologies, or are we manufacturing CO2?
No.
Man-made CO2 or?
No. So CO2 for food and beverage typically isn't coming from amine. It will come from virgin fossil fuels, because there is that argument that as amine is a hazardous substance, that moralistically companies like Coca-Cola, etc., wouldn't accept it back into if customers found out that they were using an amine-based CO2 that was captured using amine-based technology, then that could potentially be a problem. But majority of it is, yes, there's not much clarity around it. And this is one of the questions that we had. We're working with a plant, we're working with a very large client, and they said to us, just to give you an idea of what's happening in the industry, they said to us, right, can you capture 5,000 tons of CO2 for us so we can store it? And I said, okay, if I captured 5,000 tons of CO2 for you tomorrow, what are you going to do with it? And they didn't have an answer. So we educated them on the utilization piece. They went away, they spoke to BOC. BOC said, if you can capture your CO2 and you can turn it into food grade CO2, you can purify it to food grade CO2, we'll buy it off you. But you can't use amine technology. So that gives you an indication there is a desire for the industry to utilize CO2 back into industry, but because of the technology we're using, it's creating a lot of barriers.
Hi there, Mick from Dana Petroleum. You mentioned scalability earlier on in the presentation. Mm-hmm. So from my perspective with offshore assets, are we talking scalable enough to put into that kind of scale, or are you talking onshore industrial level?
At the moment, we're not doing anything offshore. It's all onshore. The systems that we design are very small. I don't know if we've got a picture of, if you go back one, just to give you an idea, if you've seen any amine technology, you see that very, very large. So we're winning a lot of projects because there's very little space around. It's fine. So this system here goes in the back of a horse trailer. It's tiny. And actually, this is over-engineered. We don't need the blue one anymore, but it probably takes up about half of a horse box. So it's tiny. And that demonstration right now we've got live, that captures 100 kg a day. Our 1 ton a day capture system with a compressor goes in a 20-foot container. 10 ton a day goes in 2 20-foot containers. So we get serious economies of scale. We're designing a 100 ton a day capture system at the moment, which is about 50 square meters. It's very small. So with regards to scaling it up, one of the things that we don't need is lots of space. So potentially, yes, there could be offshore applications for sure.
I know we're out of time, but just to follow on that last question, Michelle, about the power contribution to the cost. Would it help if you went off grid at the industrial site? Because obviously
Yes.
there's a lot of focus now on heat to power capture. We looked at a localized H2 model a couple of years ago. The idea was to design and build petrol stations with the cell H2. And on the same site, you had your wind turbine, solar,
Yeah.
blah, 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 blah. So if you went off grid on every localized application, including the heat power capture at the plant that you're trying to pull the flue, would that help?
Yes. Yeah, no, we do. We can run off renewables. So actually on our demo, we've got a wind turbine and some solar panels on there as well. We also do energy recovery. So interestingly, we were asked to demonstrate this demonstration unit for Parliament. And when we spoke about kind of it running off renewable energies, it's just see kind of glaze over. So we added a actual physical little wind turbine and some panels. And we've also added a small liquefaction system with a little glass front that actually shows the CO2 coming down, because you need to do that for politicians, you see. But that was interesting. So yes, we can do that. Everything can be run off renewables. And also we do energy recovery as well. Like I said, without the energy recovery, worst case scenario is 89% efficiency. Hi.
Just for clarity, right? You mentioned utilization, okay, but connected to the scalability question, offshore applications, right? Nothing stopped you to use this for storage, correct?
No, this is one of the spaces that we sit very, very, very comfortably in. We can be anywhere. There's nothing stopping us, even with going off grid, there's nothing stopping us from putting this anywhere. Certainly, with regards to the technology that we have, it's less about scaling up. Quite often you get the question, well, can you scale up? We don't really scale up, we scale out. The technology stays the same, we just add more vessels. And we're doing that quite easily. And actually, the bigger the vessels, the more we add, the more efficient it becomes.
Thanks, Vita. It's been so interesting so far. And I actually have another question based on the scalability of the thing. So when you're saying you have a modular system, so then you can add some more modules and then scale it up, and then obviously you need to be integrated in the plant system. So do you foresee any challenges, or what's the the biggest risk into the integration of the system?
So integration is obviously really key. One of the things we do with every single project we work on is we get full emissions data. So the only thing that will affect this system, we may need to do some pre-processing. So our system works at ambient temperatures. And this is one of the reasons why our energy consumption is so low. We don't need to do any heating or cooling. It works at ambient temperatures. That means that we can't deal with 150 plus degree flue gases. So one of the first things that we would need to do, typically flue gases are very hot, so we would quite often put in pre-processing, which is your bog standard solutions that are out there, heat exchange, and we would bring those temperatures down. The only other thing that affects our system is humidity, because our sorbent material is a dry material. So it doesn't, with amines, for example, it's aqueous amines, the CO2 at the end, it needs to be dried. Ours doesn't need to be dried. It comes out dry already. So the only thing that would affect potentially our system clogging up is humidity levels too high. But again, the heat exchange takes most of the water out as well. So just that pre-processing, but there's no issues We're working on a paper mill, we're working on a steel plant, we're working on a waste to energy plant, we're working on doing onboard carbon capture at the moment for a shipping company. So the applications are pretty much endless. As long as the space is there and we've got the flue gases, we can deal with it.
Yeah, I think we've got time for just one more quick question.
Thanks for the presentation. What is the approximate power consumption per ton of CO2 capture?
Right, okay, I'm going to do this in gigajoules, if anybody works, because I don't know what it is in. So typically it is 1.2 gigajoules per ton. If you compare that to amine technology, it's about 4.5 gigajoules per ton. That doesn't include post-processing. So amine technology requires post-processing, so you can probably add another 2 gigajoules to that. Now, we say, to be conservative, we say we're about a third of the energy requirement of an amine capture plant, but really it could be somewhere closer to a sixth.
Okay, thank you very much. And that sort of brings our session to an end. Just like to thank Bina once again for coming in here and giving us a sort of an overview on utilisation. I think, you know, it's key. It is a key element of the carbon capture cycle. And I think, you know, it is quite often forgotten about the U. So I think it's great that we can push it and bring it into the, you know, the forefront of the carbon capture value cycle. So yeah, thank you very much.
Thank you.